Okay, today let's look at reversing a linked list. So this is a very classic problem. So you're given a linked list, which is just a node linking to the next node, linking to the next node, linking to the next node. That's what a linked list is. And here's a visual example of a linked list. And essentially, you just want to swap the arrows the other way. So to solve this problem, you basically just need to keep track of the current node as well as the previous node. And you initialize the previous node as new. And so as you iterate through the linked list, you will point the current node, the next of the current node, to the previous. So imagine, right, this one right here will point to nil, as you can see here. It will point to nil. And before you do that, you just want to keep a temporary variable of the next node within the linked list, so that after you made the pointer change, you can set the current node that you're iterating on to the next on the linked list. So you also need to keep track of the previous. So essentially, anytime and every time that you have completed moving the current node's next pointer, you want to, well, you can already set the previous pointer back to the current node. So this might sound a bit confusing, but yeah, it's just pointers manipulation, and that's all it is really. So let's go ahead and do this. So the current node, we set it to the head, and then we have a previous node. We can set it as a new value. So this would default to new, and while the current node is not equal to new, we will continue to iterate. So the first thing we want to do is reference of the next node. And we now want to set the pointer to the previous node. After we have set the pointer to the previous node, we want to keep track of the current node as the previous node, as we will use this in the next iteration to point back to the previous node. And since we have set this, we are ready to set our current node to the next node. And with this, we will be able to get a reversed linked list. And in the end, we simply need to return the previous node. So let's give this a run. Submit. And that's it. So this algorithm will run in linear time, and the space complexity is constant space.